because that would take too long. Let's have a look at what used to be called some eye candy, which is here. So you can tell, here we can tell that as we move away from this point, in some directions it's getting steeper, other directions it's not so steep, so that's definitely going to be thrown out. That would, the matrix would not be positive definite or negative definite there, so it would be at points of inflection. Some other very good looking ones here. There's this one. So GeoGebra is working while I'm doing this video. So here we're at this point B, and this point here does not satisfy the first order conditions because the slope in this direction doesn't label it x or y. Perhaps this is y, I think, and this is x. They're not 0, so it doesn't satisfy the first order conditions. This one satisfies. Okay, so this is flat, but this is not flat, so that's no good. This one here, however, satisfies the first order conditions because they're all 0. And also, if I move in any direction at all, then the predicted changes are going to be decreasing. So that way, they're decreasing that way, that way, that way. Yeah. So you can see in any direction, the predicted change is decreasing. So this must be a local maximum. So d2z here will be negative. However, if I come to this point here, if I go in this direction, they're decreasing. Whereas if I go in this direction, they're increasing. So it will be neither positive definite nor negative definite. So it's neither maximum nor minimum. And if I can find the way to the bottom of a trough somewhere, here in any direction, they start to increase. So here it would be a negative definite matrix, because it'd be a positive definite matrix, because in any direction they start to increase. Whereas here it would be a negative definite matrix, which I very much hope I said after the half-hour video. So negative definite puts you here, positive definite puts you here, in the minimum. There are some even. So here's some examples you can look through from the Wakelet collection that goes with this. So this is quite a complex diagram in which we can see that the points are labelled 1, 2, 3, 4. At point 1 here, we find that the first order conditions are satisfied. Both partial derivatives are equal to 0, and the partial derivative with xx is 2. So this is positive. The whole determinant of the Hessian matrix is positive, so therefore it's positive definite, so it's local minimum. And here's the Hessian matrix up here, so it's calculating it for these different points. Next one, 2, this point here, again, both the first derivatives are 0, so it satisfies first order conditions. Fx, that's the top left entry, is positive, but the overall matrix is negative, so it's not positive definite, it's not negative definite, so it's a saddle point. You can see it is a saddle point. Some directions it goes up, some directions it's down. Point 3, this one here, again satisfies first order conditions. Fxx is negative 2, so the top left is negative 2, the whole determinant is positive 6.928, so it's a negative definite. So top left is negative, whole matrix is positive, negative definite, so it's a local maximum. And the final point is that this is negative and this is negative, so it's neither negative definite nor positive definite, so it's a saddle point again. So the only ones that pass the test are this one and this one, which are this point and this point, which are local minimum, local maximum. So the point of this test is, I certainly couldn't look at this graph and just visualize it's going to be like this. I can take this graph, I can find the first order conditions, I can find this matrix, work out these values here, and from that I can tell, without being able to visualize this graph, which ones actually are minimums, maximums, which ones are just saddle points, and identify the two optima here that we have. Okay, there's more on that collection of wakelets that's linked to from the critical points thing. There's several different complicated graphs like that, and it gives you the Hessian matrix, so you can look at it for yourself if you like. The next 2 videos. So for now, thanks for watching.